Today we are diving deep, and I mean that literally, into a revolutionary energy source that's been hiding in plain sight. What if we could use the ocean itself as a massive, completely predictable power plant?
But first, let's start with a bit of a puzzle. Think about tropical islands, right? They're some of the sunniest, windiest places on the entire planet. So why are so many of them still completely dependent on expensive, imported fossil fuels for their electricity? It's a question that stumped engineers for decades, but it turns out the answer might not be in the sky. It might be in the sea.
So to really understand this new solution, we first have to get our heads around the unique energy problem that these island communities are up against. You see, for islands, it's like a perfect storm of energy challenges. They have to import almost all of their fuel, which makes their electricity incredibly expensive, and the prices, well, they're all over the place. Now, solar and wind sound like the obvious answer, but think about it. Land is an absolutely precious commodity. You can't just pave over paradise to build massive solar farms. And if you add tricky seabed conditions close to shore, you start to see why renewables have really struggled to get a foothold.
Okay, so if you can't always rely on the sun or the wind, what's left? Well, only the most abundant resource they have, the ocean, and more specifically, the incredible amount of heat that's stored inside of it.
The technology is called Ocean Thermal Energy Conversion, or OTEC for short. The whole concept is just, well, it's remarkably elegant. It doesn't burn a single thing. It just takes advantage of a basic fact of physics. The ocean's surface is warm, thanks to the sun, while the water way down deep is incredibly cold. OTEC is all about harnessing that natural temperature difference to generate power.
Let's just walk through how it works. First, you take that warm surface water and use it to boil a special fluid, something like ammonia, which has a really low boiling point. That turns it into a high-pressure vapor. That vapor then expands, and just like in a normal power plant, it spins a turbine to generate electricity. But here's the really clever part. You then pump up icy cold water from about a kilometer down, and you use that to cool the vapor and condense it back into a liquid. And then, the whole cycle just repeats, running nonstop, 24 hours a day, 7 days a week, for as long as the sun warms the ocean.
Now, you might be thinking, okay, if the idea is so simple and it's been around for a while, why aren't we seeing OTEC plants everywhere? Well, there has always been one absolutely enormous engineering hurdle to get over.
The problem was always the pipe. See, to get that freezing cold water, you have to go deep. For a power plant built on land, this meant you had to run a colossal, unbelievably expensive pipeline from the shore, down the sloping seabed, and way out into the deep ocean. The sheer cost and the mind-boggling complexity of that one pipe made large-scale OTEC pretty much impossible.
But what if you didn't have to bring the cold water all the way to the plant? What if, instead, you could take the plant out to the cold water? That simple shift in thinking, well, it's led to a major breakthrough.
Moving the entire power plant onto a floating platform completely changes the game. Instead of that super long, complicated horizontal pipe, now you just need a much shorter, vertical one that goes straight down into the deep, cold water. This makes the whole system dramatically cheaper, way more efficient, and, this is the most important part, scalable enough to actually power an entire grid.
And here's the magic number, 80%. By putting the plant directly over the deep water, you cut the required pipe length by around 80%. That single change is what takes OTEC from being a kind of niche experimental idea and turns it into a commercially viable powerhouse.
And get this isn't just a theory anymore. A UK company, Global OTEC, has actually built the world's first floating OTEC platform, and they've installed it off the coast of the Canary Islands. Their project is now testing this system in real, open ocean conditions, which is a huge leap from computer models into tangible reality.
So what does all of this actually mean for the future of energy? It means we now have a serious new contender for providing something that energy grids desperately need. It's called baseload power. And here's the key difference. Look, solar and wind are fantastic, but we all know they're intermittent. The sun goes down and the wind stops blowing. A modern grid needs a steady, reliable source of power that's always on. That's what we call baseload power. And because OTEC runs continuously, day and night, it can provide that rock-solid foundation of electricity that other renewables so often need support with. The potential here is just massive. The company estimates that tropical islands around the world have over 25 gigawatts of fossil fuel plants that could potentially be replaced by this technology. That would be a monumental step toward energy independence and decarbonization for some of the world's most vulnerable regions.
And you can really hear the excitement from the company's CEO, Dan Greach. He says this is OPTEC's big moment.
moving it out of the lab and into the real world. And what that really means is that it can become a standardized, repeatable solution that just gets cheaper and more efficient with every new one they build, exactly like what we've seen happen with wind and solar power.
So, the next time you look at the ocean, don't just see waves. See a massive thermal battery, just holding the key to clean, constant energy. The technology is finally here to unlock it. And that leaves us with one really exciting question. What if the ocean could power our world as reliably and as predictably as the tides themselves?